Hi, it's time for another math easy solution. Today to discuss, I'm going to go over some examples on limits at infinity, horizontal asymptotes. In my earlier video, I went over horizontal asymptotes and the definition, and also some types of horizontal asymptotes. So now I'm just going to go over some useful examples. So these three examples right here. I'll start off with example 1, basically which says, find the limit as x approaches infinity of this x squared minus 1 divided by x squared plus 1. And then the part B of this question is the same thing, but we're going to negative infinity. So now if we look at example 1a right here, limit as x approaches infinity of x squared minus 1 divided by x squared plus 1. If we just look at this one right here, as you can see, when you plug in, let's say, a really large number here, you're going to go to infinity at the bottom, and then if you plug in at the top, you're going to go all as well positive infinity here. So then you're going to have an indeterminate term of infinity over infinity. And if you see my earlier video on Asymptotes rule, you could just do the derivative on the top and bottom, and that will get you. Yeah, so if we apply the Asymptotes rule right here, I just wrote it down here, we just take the derivative, or d over dx of the top, and divided by d over dx of the bottom, or the derivative in terms of x, and this is going to equal to limit as x approaches infinity of, this is going to be now 2x, that's the derivative on top, and the bottom is 2x as well, and this cancels out, and you're just left with 1 here, and this is actually the horizontal asymptote. Yeah, and I'll just write that down right here. And similarly for part B, this is going to be the same answer, because it doesn't matter if you're going infinity or negative infinity. Remember, you're going x squared, and if you had a negative number, it's going to be positive anyway. So for part B, limit as x approaches negative infinity of this x squared minus 1, x squared plus 1, we could do the exact same above, and you're going to get an answer of 1. Now if we were to graph this function, it would just look something like this, where the lowest is negative 1, you just plug in a 0, you're going to have negative 1 divided by 1, and as you can see, it's going, you have a horizontal asymptote right here, and this is at the 1 right here, so at positive and negative infinity, so it's both going to infinity there, and it's going to be at 1. Okay, so now let's look at example 2, which is basically find the limit as x approaches infinity of inverse tan of x, and then part B is the same thing, but to the negative infinity, so similar to number 1. Yeah, so I'll just write this down over here. So example 2, part A, limit as x approaches infinity of inverse tan of x. Now to solve this one, we could look at the function y equals tan of x. As remember, in my earlier video on inverse functions, this is just going to be a reflection of the y equals x line, or just the inverse. You just switch x and y's of this function, y equals tan x. Yeah, so now if we were to graph this function tan of x, see my earlier video on trigonometry, basically it looks something like this. It's periodic, and it repeats every pi, and this, it has a vertical asymptote right here at, this is going to be pi over 2, and then at over here is going to be negative pi over 2, and it keeps repeating except for the inverse. Yeah, except for the inverse function, all we're going to do now is reflect it off, or basically switch the y and x values and reflect it off the y equals x line, and it's going to look something like, because if you have a vertical asymptote over here at infinity, and this is at pi over 2, then now you're going to have, so right here if we go pi over 2, infinity, if we replace these, we're going to have infinity and pi over 2. And remember, with inverse functions, with trigonometry, you're going to ignore all of these ones, so you're going to ignore this repetition, and only this one, because it's going to rotate, it's going to look something like this. So we're going to do this. So now as you're going to infinity, you're going to be going to pi over 2. So basically it's going to be somewhere here, and it's going to be pi over 2, and you're going to have an asymptote, or horizontal asymptote, like that. And as you can see, we can't use these ones as well, because otherwise we're going to have different value. We're going to have this on top, and we're going to have two values of y for each x value. So we just look at this one here. You can see more on this on the tan or trigonometry videos in the video links below. And then similarly for this one, we just switch the negative infinity here. So we have negative pi over 2 to negative infinity, to now it's going to be equal to negative infinity and pi over 2, or negative pi over 2. And then we just go over here, and it's going to look something like this. Just draw it roughly. Okay, now I just graphed this with Google. I just replaced that drawing, I think, because it was pretty messy. As you can see, there is this is going to be now, this is inverse tan of x, and this is the tan of x right here. And as you can see, it looks just something like this, and it has an asymptote actually at pi over 2. This is at infinity, and this is going to be now at negative pi over 2. This is at negative infinity right here, and this one's at positive infinity here. So then if we scroll up and write this one, this is going to be pi over 2, and then similarly for part B, we're going to have, or just write B right here, limit as x approaches negative infinity of inverse tan of x equals 2 now negative pi over 2 right here. So it has two horizontal asymptotes depending on if you approach positive or negative infinity. And now the last example I want to go over is this one here, example 3. Basically, part A is limit as x approaches infinity of 1 divided by x, and part B is same thing but as you approach negative infinity. So if I write this one right down right here, limit as x approaches infinity of 1 divided by x, as you can see in this one, as you put in larger and larger numbers, for example 1 over 10 is going to be equal to 0.1, and then 1 over 100 is going to equal to 0.01, etc. If you keep going on into really large numbers right here, or infinity, it's going to be approaching 0 right here. So as you see, it's getting 0. This is getting smaller and smaller. It's going farther and farther here in the 0 column there. And as you can see, this is just going to be approaching 0 right here. So this is actually the answer. And similarly, if we look at part B, which is limit as x approaches negative infinity, again you could use the same approach above, but now you're approaching negative. So if we look at 1 divided by negative 10, we're going to equal to negative 0.1 right here in front, and then similarly 1 over 100, negative 100, you're going to equal to negative 0.01. So as you get larger and larger, you're approaching again 0, but from now the negative side. So once again, as you approach it, if we keep approaching it to now negative infinity, we're again approach 0 right here, or negative 0, it doesn't matter. It just, you can't have a negative 0, so just 0. So it's approaching 0. Doesn't matter for part A and B is approaching infinity or negative infinity, you're still approaching 0 right here, but now you're just approaching from a different side. Yeah, so now if you were to graph this function, I've graphed it with Google Calculator right here. As you can see, it's approaching 0 as you go to infinity right here, and it's approaching again 0 as you go into negative infinity, but it's approaching from the negative side of this x-axis right here. And also there's vertical asymptotes. Now here this is going positive infinity, because as you're going to 0, in this case 1 divided by 0, it's going to go to infinity, but now in this case you're approaching 1 divided by 0, but from the negative side, and again it's going to go to negative infinity right here. So yeah, basically 1 divided by a really, really small number, but negative is going to go all the way to negative infinity. This one is a horizontal asymptote at 0 right here. Well, that's all for today, actually. I hope you learned from these useful examples, and make sure also to watch the video on, basically the video before this one on horizontal asymptotes, where I go over the definition, etc., to get a better idea. Well, that's all for today. Remember, you can always download these notes in the Dropbox link below, and stay tuned for another math easy solution.